So now I'm going to show you how to draw shockwave diagrams. That's what we need to do. That's going to be part of your homework tonight. That is going to be your homework tonight, is to draw some shockwave diagrams for us. So what we're going to do is we're going to make a diagram of an aircraft which is going Mach 3. Okay, Mach 3, which, as you recall, means that the plane is going at 3 times the speed of sound. Speed of sound. And again, as you recall, the Mach number is the ratio of the speed of the plane divided by the speed of sound. So, for example, if the plane goes 3 miles in the time that it takes the sound to go 1 mile, that means that the plane is going 3 times as fast as the sound, which equals Mach 3. Now, it doesn't have to be miles. It can also be inches or centimeters. So what you'll need for this, to make these diagrams, is you're going to need a ruler. Ideally, it should be a centimeter ruler, but you can do it with an inch ruler. And then you will need a penny also if you're using the centimeter ruler, or a quarter if you're using the inch ruler. Turns out a quarter is about 1 inch across, and a penny is about 2 centimeters across, which is very useful for us. So I'm going to do this with the quarter first. We'll do it in inches because I think all of you probably have inch rulers. And what we're going to do is we're going to make a line along here. This is going to be the path of our imaginary airplane, and we're going to make some marks here that are 1/2 inch apart. 1/2 inch apart. And this keeps track of how far our airplane has gone or how far our sound has gone. That's way plenty on the marks. Okay? Now we're going to pretend that the airplane was at this point right here. We're just kind of choosing that arbitrary. And we're going to make the sound wave that is going to be made from when the plane is here. So when the plane is at that point, it's going to make sound. And eventually the sound is going to expand so that it is that big. Now, the sound in reality expands in a sphere through air, because air is 3-dimensional, but when we're doing it on paper we can just treat it as a circle. Okay, so the airplane was there at some point in time, it created sound, and after we wait a little while the sound has traveled that far in all directions. Now the airplane is moving 3 times as fast as the sound. This is a Mach 3 plane, so the plane has moved 3 times as far as the sound. So the sound has gone this far. That's 1 unit, 1/2 inch on this scale. That's how far the sound has gone after we've waited a certain period of time. And in that same amount of time, the plane has gone 3 times as far. So the plane goes 1, 2, 3, and the airplane is right there, touching that dot. Right? Now, what we saw before is the shock wave will go from the from the nose of the airplane and be drawn so that is very carefully exactly tangent to the edge of that circle. Remember, a tangent line is a line which intersects the circle at exactly 1 point. And that's how we draw it, because that's how far the sound has gotten. We draw another one for the top side here. Be real careful. There it is. And that's a Mach 3 cone. A Mach 3 shock wave, or a sound cone, or a wave cone. Right? So to review, we have to have some kind of reference gauge here, and in this case we used 1/2 inch intervals because it goes well with a quarter. In the time period that we waited, the sound traveled 1/2 inch, which means it made a circle or a sphere that was exactly 1 inch in diameter. And in that same amount of time, when the sound traveled that far, the plane traveled 3 times as far, because we want to make a Mach 3 diagram. So the plane went 1, 2, 3. This is where the plane is. and then we drew our line from the nose of the plane, just touching the circle here. Now, we could draw a circle for any moment in time where the plane was at any moment in time, and its sound would expand so that it is just meeting this cone. So if we know the position of one sound wave, we can figure out where all the sound waves are, and this is the shock wave that forms. Okay, now I'm going to do this again with the penny using the centimeter scale so we can see it again. I think that's still centered in the frame. Yep, we're still good. Alright, so I'm going to do it down here, make a line. This time I'm using centimeters. The nice thing about centimeters is you can just count the centimeters. You don't have to count half inches. So I'm going to make marks each centimeter here. Make a few of them that's more than we need. That'll be fine. And we're going to say, all right, the plane was at this point. We're just going to choose one kind of arbitrarily here. And we're going to lay the penny on there to make the circle which represents our sound after a certain short amount of time. There we go. Why are we using a penny? Because it turns out that a penny makes a circle that is almost exactly 2 centimeters in diameter, which is very convenient for us. Okay, so when the plane was there at the center of the circle, it produced a sound pulse, and the sound started moving out in all directions. And after a certain amount of time, the sound made it that far. That's 1 centimeter. Now, if the plane is going 3 times the speed of sound, if the sound moved 1 centimeter, that means the plane went how far? 3 centimeters. So we count 1 centimeter, 2 centimeters, 3 centimeters, and our plane is going to be right there after that same amount of time. Then we draw our cone. There we are, touching that circle in exactly 1 point, just like that. And this is the reason I'm doing both of these for you. As you can see, the angle is the same. This angle of the shock wave depends on the Mach number. And any Mach 3 cone that you make is going to be this same angle. It doesn't matter how fast, it doesn't matter how much time you spend, you wait. Doesn't matter how far the sound has gone. The ratio of how far the sound goes, this ratio here, to how far the plane goes is always going to be 3:1 for Mach 3. That's it. Now let's think about it for a moment. What if we did a Mach 5? Would it be a sharper cone or a flatter cone? If you think about it, well, if it was Mach 5, the plane would be all the way up here, and it would be a sharper cone. It was only going Mach 2, the plane would be here because the plane started making the sound here. The sound went 1 unit, the plane would go 2 units, and so we'd be making a flatter cone. All right? So that's how you do it. That's how you make shockwave diagrams. Now, how do you analyze shockwave diagrams? How do we analyze? Well, that's pretty easy. I might give you a diagram like this and say, hey, how fast is the plane going? Give you this kind of a diagram. And you'd say, well, when the plane was here, it was making sound, and the sound went that far. And when I measure it, that is 1 unit. From here to here, 1 unit. And how far did the plane go in that amount of time? Well, the plane went 1, 2, 3 units. So the plane went 3. When the sound went 1, that equals Mach 3. That's all there is to it.